evaluate them. So the first thing I'd like you to do is take a look at these two sigma notations and come up with what the sum would be for in each situation. So you can pause the video. When you restart it, we'll talk about what those two become. So hopefully you found these two answers, right? That the sigma notation of the first one, you ended up with 55, and the second one you ended up with 63. So if we look at where that comes from, trying to think of a pattern there, right? If we look at the first term and the last term, right, and we look at what those added together would be, hopefully you see that that's 11, right? And then we say, okay, well, if I look at the second term and the second to last term, oh, those also add to be 11. And if we continue looking at this as we work our way towards the center, you can see that each one of these adds to 11. And, right, there is 5 sets of 11, and 5 multiplied by 11 would give me the 55 I'm looking to. Does that pattern hold for this second thing? So if I look at the first term and the last term here, and I add those together, I get 21. Well, does the same thing work here? 15 and 6, 21, right? And then, oh, the middle ones, that again, 21. And 21 multiplied times 3 would give us our 63. So if we look there, could we try to figure out how could we shorten this idea of if I have a sigma notation or I'm looking to sum up some arithmetic sequence, right, where we have a linear equation, right, what could we use? And if you notice there, the number of 11s or 21s we have is half of the total number of terms. So that leads us into our idea of there is a formula that we could use to sum up a finite arithmetic series. Okay? Now, let's take a second to think about yesterday we talked about sequences. A sequence is just a set of numbers, right, where we start at A1, and then we have A2, and then we have A3, all the way on till we get to AN. So it's an infinite set of numbers, right, that follow the A pattern, right? Where the main difference now is in a series, right? A series will take those same numbers, that is arithmetic numbers, but now we are looking to find the sum of them. Okay? And so if we have that difference known, now we can look back at our pattern that we just talked about here. Okay, so we said, if I look and I say I take the first and the last number and add those together, and then I'm going to have that sum, the number of terms divided by 2. So the sum of a finite arithmetic sequence is if I'm looking to add up the sum of the first n terms, right? We're going to take that number of terms, divide by 2, and we're going to multiply that by the first term multiplied by the last term. First term plus the last term. Okay? So you can see that S of n equals n, the number of terms divided by 2, multiplied by the first term plus the last term. So that is the basics there of what we are going to look at today. Now, the problems you were asked, you're probably never going to be given just those 3 pieces of information straight up and just told go for it, right? So we're going to have to combine this information with the memory we have of our explicit form of an arithmetic sequence. So if we look at this first one, we're like, okay, find the indicated sum for each arithmetic series, right? So the first thing is I'm just looking and I'm like, okay, how am I jumping from one to the other here? And it seems to be we're at plus 9, right? And it continues, it's plus 9 every time. So we can see that pattern holding, right? Then, okay, so I'm thinking it is arithmetic. So I want to know S of n, right? The sum of those numbers is going to be n, some number of terms divided by 2. And we know the first number, right? We know that the first term is 15. We know that the last number is 23 in our sequence. What we don't know is we don't know what n is, because we don't know right here, we don't know what term number 23 is. How many times did I have to add 9? Well, you could start at 15 and just keep adding 9 and keep track in your head and do that, but that's going to just it's going to take a long time. The other thing we could think about is we could say, well, we remember this formula. if we need to know any term, we can just take the difference between the terms multiplied by n minus 1 plus the first term. Well, we know that the last term is 213. We know that the difference is 9, and we're looking for n. And we're starting at 15, right? So you do a little algebra there, right? You would have, subtracted your 15, get 198, 9, and minus 1. Okay, that's 22 then. So 23 equals n. Well, now that I know that, I can take that n and replace this, and now we have this in the calc. Now we have our completed formula. So when we actually do that math, right, we're able to come up with that the sum of terms 1 to 23 in this arithmetic series from starting at 15 all the way to 213 is 2,622. Okay? So these problems continue just doing these kind of same things, right? So if we're going to take a look at a couple more and then you'll just be turned free to practice these, is if we look here, we're like, okay, another sum, right? So 34th partial sum, that means that is our value n. We know that here is A1, but what we don't know what the 34th term is. So when we go to make this one up, the sum of n, the sum of term n, so we know 34 over 2. We know that this is going to be 35, but we don't know what we're adding it to at the moment. So that's what we're going to have to figure out. So again, back to our explicit form over here, we would say, well, I don't know what this is, but I do know what's my difference here. Minus 21, right? So we're minus 21. We need to get to term 34, and we're starting at 35. So you do the calculations there to figure that out, and you get negative 658. Well, I'm able to take that now and replace in here. And again, completed formula. Now we can plug this in, right? So then when we do that, we're getting negative 10,591. So there's your answer if I added up the first 34 terms in this equation. So that's the basics of this, right? Again, there can be a couple different things, right? And you can see in number 3 and number 4, it presents a different problem, but these are, again, going to follow this same idea. So if we look at number 3, and then we might skip down and do one more here, but in number 3, okay, if you notice, the big thing here is that it is not starting at 1. In all these other ones, we've been starting at term 1 and moving forward. So here, if we're not starting at term 1, but our only process that we have right now, right, because S, if we sum n, it's always starting at term 1 and going to the end, right? So it's always looking for that. But that's not what we're looking for right now, right? We only want to know a group that goes from 15 to 37. Well, if that is our only process, what if we also have, could we go from 1 to 15? Sure, right? So if you look at this, we could think, well, what we really need to do is we need to say S of 37 minus S of 15, sum from 1 to 15. So if you do that, right, you could start to figure this out, right? So if we have this, right, and I'm going to write this part here, okay, so this is going to look like for us, right, 37 divided by 2. Well, I don't know what the first term here is. Well, how could we figure that out, right? Well, if we plug in 1 to this equation, right, so if we plug in 1 to our equation, A of 1, that would be negative 3 times 1 plus 2, which is negative 1, right? And then we would also need to know, in this case, A of 37. Well, that would be negative 3 times 37 multiplied by 37 plus 2. Well, negative 3 multiplied by 37 plus 2 is going to be negative 109. So plus negative 109. So that is term 37, the sum of the terms 37. Well, what we know is then we're going to have to subtract what we get if we do the first terms, the first 15. Well, we start at the same place, but then we're also going to need to know A of 15, negative 3 multiplied by 15 plus 2. And When I get that, I get negative 40. So plus negative 40. Now we have our whole equation, and when we multiply that all out, we will end up with negative 1,748 as our sum. Okay? And so you can see here, we have the three main types of problems, right? Where you are missing some part of information. In number one, we were missing the term number. In number two, we were missing A of n. And then in number three, right, we had a difference where we had to do two sums and subtract. And then we also had to find out what the first term and the last term were in both of those situations. So I hope this helps as you continue to look through this unit and this lesson.